According to a new study from MIT and other universities, there may be more than a quadrillion tons of diamond hidden in the Earth's interior. But the new results are unlikely to set off a diamond rush. The scientists estimate the precious minerals are buried more than 100 miles below the surface, far deeper than any drilling expedition has ever reached. The ultra deep cache may be scattered within cratonic roots, the oldest and most immovable sections of rock that lie beneath the center of most continental tectonic plates. Shaped like inverted mountains, cratons can stretch as deep as 200 miles through the Earth's crust and into its mantle. Geologists refer to their deepest sections as roots. In the new study, scientists estimate that cratonic roots may contain 1 to 2% diamond. Considering the total volume of cratonic roots in the Earth, the team figures that about a quadrillion, that is 10 to the power of 16 tons of diamonds, are scattered within these ancient rocks 90 to 150 miles below the surface. The researchers came to their conclusion after puzzling over an anomaly in seismic data. For the past few decades, agencies such as the United States Geological Survey have kept global records of seismic activity, essentially sound waves traveling through the earth that are triggered by earthquakes, tsunamis, explosions, and other ground shaking sources. Seismic receivers around the world pick up sound waves from such sources at various speeds and intensities, which seismologists can use to determine where, for example, an earthquake originated. Scientists can also use this seismic data to construct an image of what the Earth's interior might look like. Sound waves move at various speeds through the Earth depending on the temperature, density, and composition of the rocks through which they travel. Scientists have used this relationship between seismic velocity and rock composition to estimate the types of rocks that make up the Earth's crust and parts of the upper mantle, also known as lithosphere. However, in using seismic data to map the Earth's interior, scientists have been unable to explain a curious anomaly. Sound waves tend to speed up significantly when passing through the roots of ancient cratons. Cratons are known to be colder and less dense than the surrounding mantle, which would in turn yield slightly faster sound waves, but not quite as fast as what has been measured. The team aimed to identify the composition of cratonic roots that might explain the spikes in seismic speeds. To do this, seismologists on the team first used seismic data from the USGS and other sources to generate a three-dimensional model of the velocities of seismic waves traveling through the Earth's major cratons. Next, the researchers, who in the past have measured sound speeds through many different types of minerals in the laboratory, used this knowledge to assemble virtual rocks made from various combinations of minerals. Then the team calculated how fast sound waves would travel through each virtual rock and found only one type of rock that produced the same velocities as what the seismologists measured, one that contained 1 to 2% diamond. The researchers found that a rock composition of 1 to 2% diamond would be just enough to produce the higher sound velocities that the seismologists measured.